Hello, higher algebra students. Our first lesson here of Unit 5, which is graphing systems of equations. So the first part of it is really remembering how to graph the linear equations, which we talked about in Unit 4 a little bit. And then the second part is then this finding solutions to the system. And we'll talk about that in this lesson about what a system is. So for instance, if I am asked to graph the following two lines, so again, we always look for start at that y-intercept, which is at the point 0, 3. And our slope here is 2/3. So again, that's rise over run equals 2/3. And they're both positive. So again, a positive on the rise means you go up. And a positive on the run means you go to the right. So I'm going to go up 2 and over 3 to right there. And then up 2 and over 3 to right there. And I could go down 2 and back 3 if I wanted to, as long as I make it both. That would be a -2 over a -3, which is the same thing. And then I graph that line. And again, I'm going to put arrows at the end because I don't have an endpoint to that line. So for instance, that's one line on its own, right? And so now we look at this second equation. Again, -x is equal to -1x, which for rise over run would be -1 over 1 or 1 over -1x. Those are all the same thing right there. So the intercept here is -2. So I'm going to start this at 0, -2. And again, I could go, this one here would be a fall of 1 followed by a run of 1. A fall of 1 followed by a run of 1. So it would look like this. Or I could use this one, which would be up 1, but then back 1. Up 1, and then back 1, and so on. So that equation looks like this. Okay, so we have both of these, and what you would see here is if I did have these on the same graph, that at some point these two lines would cross. Okay, and where they cross then is the idea of solving the system. So in other words, if we had to follow both these rules, where do they intersect? Okay, and so we'll start to then put these graphs on the same individual coordinates or same graph, and so we'll look at that. So we look here at, now here's both graphs a little cleaned up, looking at where would these intersect, and again, that would be the solution that works for both. In other words, you could put that x into the equation and it would work for both of them. So as we look at this, we'd essentially take the graph, I'm going to take the graph on the right and move it over here. So if I go to -2, where the intercept was, and I'm going to just go up, okay? So it looks like this, and so where that intersects here is where we would find that answer. So it looks like it would be at the point -3, 1. Okay, so if we put in -3 into each equation, so 2/3 times -3 plus 3, and then -3 minus 2. Okay, so that looks a little different there. You do have to remember that the negative from the beginning in front of the x is this, and then the actual x is a negative on its own, so that's why it's a -3. So 2/3 times -3, 2 times -3 is -6. That's -6 over 3 plus 3, which is -2 plus 3, or 1. Similarly here, a -3 is a positive, and 3 minus 2 equals 1. So that tells us here that the answer, -3, 1, that coordinate is where these two lines intersect, which means that coordinate is an answer to both equations. If you put -3 in for x, you will always get 1 for y in both equations. So that would be the solution to this system of equations would simply be the point -3, 1. Okay, so that's what we're looking at. Okay, and let's forward. So here we go. The way these will be presented is actually both equations in one shot like this. So you'll start to see this here where it just lists them with this little bracket to the left. Okay, that shows that these equations are together as a system. Similarly, you could get it in a graphical representation where we have um, both of them graphed on an axis already, and you're just looking for that intersection point. This is a little more of kind of it leads you almost essentially to the answer, and you're just trying to identify that point. And then as we get further along, we'll start to look at what happens when, for instance, one of the lines is not linear, and there's two answers to that system. So all these will be at some point in our future. And let's start by just the idea of kind of at ground level. Finding a solution is like for us right now is really just finding that intersection point between the two graphs. So what we're going to do in terms of our steps is we'll graph those two lines on the same coordinate plane. You do have to keep in mind that if the equation is not already written as a y equals, so for instance, if it's 3x plus 2y equals 8, you do have to solve for that y first before you can graph it, or at least make it much easier to graph if you solve for that y first. And once you graph both of them, once after you've solved them both for y, if they aren't already, you graph them and then you find that intersection point, and that becomes our solution. And you write the answer in this format right here. Notice there's not a space after the y, after the comma. That's how we'll write them just to kind of keep it consistent, so there'll be no spaces in there forward. So here we go. This one here, we've got both equations already solved for y. Okay, so in this situation, we do not need to do any solving for y, so it's really just now taking these over to the graph. So this first one here, negative x minus 6. So I'm going to go down 1, 2, 3, 4, 5, 6, and put my intercept. Okay, and negative x again means it's negative 1x, or negative 1 over 1x. Okay, so my slope here is negative 1. So I'm going down 1 and over 1, or I could go up 1 and back 1. Okay, and that is my first line. Okay, so that one's taken care of. So now we're going to switch over to line number 2, which has an intercept of negative 2. Okay, and what you'll see here is the slope is 3 over 1. So we rise 3 and run 1, and then rise 3 and run 1. But you can see at this point we aren't crossing over the black line if we keep going this direction. We could draw in the red line now, but you have to make sure you're very exact about drawing that in to make sure that you have it cross the black in the right point. So what I would recommend is, rather than drawing it yet, let's actually go the other direction first. So instead of going up 3 and over 1 like we have been, let's go down 3 and back 1. And that just confirms that the overlap point is right here, at that point right there. Because if I draw this graph, and again, I maybe would have landed there anyways, but if you don't put that point there, sometimes your line, this line here, could get tilted, like you can see mine is right now. It's not perfectly straight. And so I can confirm that this point right there is my intersection point because I drew dots for both lines on that exact coordinate. So the x value there is a negative 1. And the y value down, let's see, let me bring in a different color here. The y value is down 1, 2, 3, 4, 5. So the point negative 1, negative 5 is what we believe to be our intersection point and the solution to this system of equations, but we could verify it too. So I'm just going to go back really quickly here and put into my first equation, y equals, again, there's a negative already, but then my x is a negative, so that's why we take that negative to go there, and then the x value is negative 1, and we subtract 6. So that is 1 minus 6, which is negative 5. Okay, that's a good sign. Now, the other equation, the one that I drew with the red line here, I'm going to do the same thing. So I have y equals 3, my x is negative 1, and then I'll subtract 2. 3 times negative 1 is negative 3. Negative 3 minus 2 is negative 5, because again, you're already negative and you're getting more negative. So that one also matches. So we know that our answer here of negative 1, negative 5 was in fact correct. All right, so another potential question again would be one like this, where we do not have both equations solved for y already. So First thing we're going to do is just solve them each for y. As you can see, the top one here will be pretty quick because we just need to subtract the x from both sides. So I'll just write it down here again. So I'm going to subtract the x from both sides. And that gives me my equation, y equals, and I'm going to put the negative x first just to keep it in the format that we're used to, the mx plus b format. So that one is taken care of. Now the second equation, which is now negative 3x plus y equals 2. It's nice that these already have just y alone, so all we have to do here is add the 3x. And so my second equation here is y equals 3x plus 2. So I'm going to go up and graph each of these. I'll keep the red with the red. So this is an intercept of 6. So I'm going to go up 1, 2, 3, 4, 5, 6. My slope here again is negative 1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And again, it's negative 1 because that's negative 1x there. Or negative 1 over 1 or 1 over negative 1 or however we want to write it again. And now I connect those dots. Okay. Now I'm going to go to my blue, and I've got an intercept of 2 here, and my slope is 3 over 1, so I'm going to rise 3 and run 1, and thankfully, right out of the gate there, I end up with the overlap point, which is right there, the yellow point. So I don't need to really continue necessarily. I mean, I could go down 3 and back 1 to keep this line. I could go up another 3 and over 1 to get some more dots to connect. But the main goal was to figure out that point right there, which is the point 1, and then let's see, 1, 2, 3, 4, 5. So the point 1, 5. And again, I can put these values back into the equation, and now when I put them back into the equation, I actually have a choice. I could put them back into the original equations, or I can put them back into my solve for y equations. It doesn't really matter. If I put them back into my original equations, the first one's really quick because it's just 1 plus 5 equals 6, since the x is 1 and the y is 5. The second one is negative 3 times 1 plus 5, which is negative 3 plus 5, which equals 2, which is what it was supposed to equal. So that's good. Both were positives again. We could, like I said, put them both into these equations as well, and we would find that those work also. All right. So there's 3 big cases that you need to be aware of. The one we've worked on so far is just case 1, where we have 1 with a positive slope, 1 with a negative slope. And anytime there's 1 with a positive slope and 1 with a negative slope, or they're both positive but different, or both negative but different, they will eventually meet. And again, a both positive but different would be like one is pretty steep and another line is less steep. If they're both negative, it could be that one is really steep and another one is less steep. Okay, so these are both negatives, these are both positives, but they're still going to intersect as long as they aren't the same slope. The second case is if they are parallel. If the slopes are exactly the same, then there will be no solutions. Okay, and what it means is if they're parallel, they just never intersect, and so no solutions will be our answer if we find a situation where the slopes are the same. Okay, so keep that in mind, that no solutions is the kind of preferred way to state that. Case 3, it looks like there's only one line here, but case 3 is actually if the 2 lines are the exact same line. Okay, so what I mean by that is there's a blue one there, but there's also a red one right on top of it. Okay, and when that happens, then our answer is going to be many solutions. And that just means that any point you put in is going to work because it's going to be on both lines as long as it's on one of them, whether it's here or here or here or here or whatever, for on and on. So many solutions is the terminology you will see around case 3. Okay, we'll leave it at that. Appreciate you watching, and as always, if you have any questions, let me know. We'll talk about the assignment in class. Thank you.